Welcome to the AMA. This is the question from November 3rd. So I'm going to give you a chance to check it out. It's one chart, but it's actually two questions. Okay, so as you can see, they are both probability questions, and they're asking just slightly different questions, and that's why I want to look at them both separately and kind of compare the two of them. So, the first thing that you want to remember is that probability is really about setting up a fraction. So let's read the two, just the question part. So for 13, it says that what we're trying to find the probability of is an undergraduate is Black or African American, given that the student is a male at the university. And then question 14 says we want the probability that a randomly selected undergraduate at this university is either Asian or a female. And so if we want to set up this fraction, we want to think about what's going to go in the numerator and what's going to go in the denominator. And you'll notice that in the two questions, I have some things underlined in red and some things underlined in blue, and they are not before the same word. So we've got this like given, and you have this word is, and in number 13, it goes red, given blue, and in number 14, it goes blue is red. So we want to remember with probability is they're not always going to set up the same way, like numerator, keyword, denominator, yeah, or vice versa, right? Instead, you really have to think about what is your total, yeah, your total population that you're drawing from, and what is your desired, what are you hoping to sort of select out, right? I have a bag of marbles, that's my total, and I'm trying to pick a particular one or a particular color. That would be my desired, right? So we want to remember that the desired is our desired outcome, sorry, is our numerator. So what is it that we're hoping for? Well, in 13, we want that person to be, that undergraduate to be Black or African American, right? And in number 14, we want that of that randomly selected to be either Asian or female. So that's where our numerators are coming from. So our denominators are going to come from what the pool is. Well, that's where this given comes from in number 13. It's saying given that the student is male. Whereas in number 14, it says randomly selected from the university. So our denominator for 13 is going to be all males, but our denominator for 14 is going to be any undergraduate, right? So now all we have to do is go to our chart and figure out what numbers go with that. So let's look at number 13 first, right? So we want African American male. So that means we're going to start over here at male. We're going to come across Black or African American. And here we have our 594. We want all males. So we're going to use this total number. So it's going to be 594 over 6,600. Now, for number 14, there's actually two ways to look at this. So let's look at the first way. If we want Asian or female, we could say, oh, okay, well, all Asians is 1,482. And oh heavens, I see that I have accidentally made a typo in my slide, 1,482. And then we might say, oh, all female is 5,400. But the problem with that is that would mean that we had counted this group that is Asian and female twice. So if we use the 1,482 and the 5,400, then we have to take out anyone that's going to cover both. Yeah. And then again, because we're doing out of all the people, right, randomly selected from the university, our denominator is going to be 12,000, right? Comes from this number right here. So if you're like, I don't really think I think about it that way, then here's another way to think about it. We're looking for all females, right? So that's this 5,400. or Asian. Well, if we've already counted this 642 in our adding across the way or looking at what all of our potential females are, then really the only number that we're going to include is 840 because that would be someone who is Asian and males. We didn't count them the first time. So that would be 840 plus 542. But I'm just going to go back to our previous slide real quick. Do you see how we get that same number, 6,240? So like so much in math, you can think about it a couple of different ways and we can still get that answer. So whichever one sort of makes more sense to you. So now all we're going to do is just perform that division, turn it into a percent, right? This just means that when you do the division, you'll get a decimal and then move that decimal over two places. So what you get is about 9% for question 13, right? For our Black or African American out of males. Yeah. And for number 14, we get about 52%, which is the probability that you would be Asian or female out of the whole population. So out of the 12,000. All right. Okay. Happy practicing.